Hello students, today we are going to do another concept called as vapor pressure. You will find correlation for it in terms of Raoult's law and colligative properties. So we first need to understand the basics of it. Vapor pressure. Pressure of the vapor above a liquid is called vapor pressure, right? If you see it in terms of a simple definition, this is how it will look like. What is vapor? How is it formed? We have a liquid here. The particles of the liquid are continuously in motion, random zigzag motion. These particles, they collide with other particles of the liquid which are again in continuous zigzag motion. Due to this collision between two particles, exchange of energy happens, because of which one particle will lose energy, the other may gain. As we know, energy can neither be destroyed nor be created, it only changes its form. So, the particles which are there on the surface have a tendency to escape from the surface of the liquid if they have enough kinetic energy. When they escape, they will lose energy. When they lose energy, they will fall back into the liquid. In other words, we have two processes going on simultaneously. One, evaporation of the liquid, that means conversion of liquid into the vapor state, and condensation of the liquid, that means conversion of the vapor particles back into the liquid state. It is not possible to measure the pressure of the vapors over this liquid in such an open container. So, what do? We have a setup here wherein we've got the sample liquid or the liquid whose vapor pressure is to be measured in a conical flask. This can be a liquid, a solution, a mixture of two liquids, anything it can be. We take it in a sealed conical flask. We in turn connect it to a U-tube over here which contains mercury as a liquid. This is what we call as a manometer, a device to measure pressure. We need to maintain the temperature as constant over here. The reason for this we shall be studying a little later. So we maintain the temperature constant by means of a thermostat arrangement, probably surrounded with hot water whose temperature is maintained constant. Now, once the experiment begins, we notice that as the process starts, that is, the particles of the liquid start vaporizing, we will find that the mercury in the right limb of the manometer begins to rise. This begins to rise, this begins to fall. The reason being that the vapors which are escaping from the conical flask will try and exert pressure over this mercury. Now, after a certain while, this mercury will stop rising up to after a particular height. Why has this happened now? That is because a state of equilibrium has been attained. That means the rate of evaporation has become equal to the rate of condensation of the particles back into the liquid state. This is what we call as an equilibrium. It doesn't mean that the process of vaporization or condensation has stopped. It only means that both processes are taking place simultaneously but at the same rate, at the same speed. Now we take the difference in the height of the mercury in the two columns. This is H. You know that the formula for the measurement of pressure is P is equals to H dG. H is the difference in the height of the mercury column. D is the density of the mercury you have chosen. G is the gravitational acceleration. And this gives us the pressure. In other words, if we have to define vapor pressure scientifically, how will we define now? So vapor pressure is the pressure that the particles of the vapor of a liquid exert over it, provided the two of them are in equilibrium with each other at constant temperature. This is what we call as vapor pressure. So when we define vapor pressure scientifically, the two important words over here for us are that the liquid and the vapor should be in equilibrium. The temperature has to be maintained as constant. Again and again we are saying that the temperature needs to be maintained constant. Why? First, we see that when you will increase the temperature, the kinetic energy of the particles will increase. Now, when the kinetic energy of the particles will increase, they will tend to leave the surface of the liquid faster. In other words, temperature will affect the vapor pressure of the liquid in this setup. Now, supposing I increase the temperature of this thermostat, we reach a stage where the vapor pressure P becomes equal to the atmospheric pressure. In other words, the difference of the two pressures comes to 76 mm of mercury under the standard conditions. Now, once this is achieved, this liquid starts boiling, and that is temperature at which the vapor pressure of the liquid becomes equal to the atmospheric pressure is what we call as the boiling point of the liquid. So with this experimental setup, we can also determine the boiling point. So boiling point is the temperature at which the vapor pressure of a liquid becomes equal to the atmospheric pressure. Second factor which affects vapor pressure, the nature of the liquid. I've taken very simple examples over here. We've got water and we've got ether. You know very well that in the case of water, the molecules are linked to each other by an interesting type of bond, what we call as hydrogen bond. Because of this hydrogen bond, the water molecules are very closely knit with each other. They are closely attached to each other. So if you ask them to separate, you will have to apply a lot of energy or a lot of heat. In other words, the particles of water will not escape easily. In other words, the vapor pressure of water will be lowered. Take the case of ether. There's no hydrogen bonding happening over here. In other words, there is no love lost between the two ether molecules. So what will happen is when you heat it, this will escape easily. So the vapor pressure of ether at the same temperature as of water, if we compare the two, the vapor pressure of ether is more than that of vapor pressure of water at the same temperature. So accordingly, if the vapor pressure is less, that means it will take a longer time, it will take more heat in order to bring the vapor pressure of water or any liquid to its atmospheric pressure. Hence, the boiling point of water is not much higher than the boiling point of ether. Thus, in the case of ether, the vapor pressure being higher, the particles will reach the atmospheric pressure very easily. Third we come to is impurities, volatile, non-volatile. Two types of impurities that we can add to a liquid. Volatile means they themselves will evaporate. Now when they themselves will evaporate, they will affect the vapor pressure. How they will affect, we shall do in a separate law, that is the Raoult's law. Then we add non-volatile impurities. Non-volatile means which will themselves not evaporate. They also affect the vapor pressure. Since they themselves are not evaporating, we shall see later when we do the colligative properties as to how such non-volatile solutes affect the vapor pressure of the liquid. I hope this helps to understand the basic idea about vapor pressure. In the second video, we shall be talking about Raoult's law for volatile solutes.